Let's continue NumPy. NumPy stands for numerical Python, and the main purpose of NumPy is to work with arrays. Okay, and it's similar to list, but there are few differences that we'll see in a few minutes. And with NumPy, we can apply mathematical operation directly in arrays. Okay, for instance, to find mean, max, and median, mean values, and it's a widely used library in data analysis and machine learning. Now let's import the library. So the keyword we use is import. Name of the library is NumPy, and as np is again a short name similar to pandas as pd. Np is a short name for NumPy. And so with NumPy we work with arrays. Now let me create a sequence of numbers. So now let's assume that we have student grades, and that will be np array. Okay, that's an np and an array, and we have few grades in this arrays. Let's assume we have 78, 90, 99, 76, 88, and the last one, let's assume the 56. Okay, and with NumPy we can apply mathematical operation directly in arrays. That's the thing. And let's assume I need to find the minimum value. So there are two ways to apply these functions. One is to use np functions, and the second one is to use object to find object to call the object methods. Okay, and if you use functions, that would be np. Okay, that's an np. Why? Because that's a short name we have. And now I'm going to find the mean. Okay, the mean value of this array, you will see it will print out the mean value of this array, that is 81.16. okay, that's a float value. And if you use print around this function, okay, that's the function we have got 81.16. okay, so I use function here. Okay, that's the difference. Let me explain again. That's a function we have. And in case if you need to find minimum value, so that's a mean. And if you need to find the minimum, that's np.min, and the array name is this one. We have the minimum value is 56. All right, and then there are few functions that we have is to find the position of minimum value and the position of the maximum value, and that is np.argmin. okay, and array is student grades, and if print or it's index 5. okay, it's an index 5. We will see indexes in a few minutes. So it's saying it's index 5. So 0 1 2 3 4 5. I will explain in a few minutes. And let's say we need to find the position of the maximum value, that's index 0 1 and 2. okay, and that will be print. And so these are the functions we have. I'm just looking few functions that we have with NumPy, and that argmax, and the name of the array is student grades. So it's on index 0. okay, so it's saying 0 1 and 2, so it's on index 2. It's similar to list. Indexing and slicing, it's very similar to list. For instance, the first value 78 is on index 0. okay, that's we have np, so it's an np int 64, and the value is 78, you'll see. And if you use the print, that's a 78, that's index 0. And okay, indexing is very similar to list, and the second value is index 1, and the third value is index 2. okay, use 78, 90, 99, and the fourth value is on index 3, because indexes start from 0. That's why the fourth value is on 76 on index 3rd. That actually is fourth value we have. And then we have fifth value, that is on index 4, and the last one is index 5. okay, that's very similar to list. okay, these are all values we have. okay, and in case if you need to extract these all values using a loop, that's very similar to list. We have for, let's say, val is a variable we have for val in where. That's from here we want to extract value using a for loop, and then it will print val. okay, these are all values we have, and we extracted using loop. Why? Because there's a pattern there. You see 0 1 2 3 4 and 5. That's a pattern, and that means the step is 1. So you can easily extract values from NP array. Another important thing is that if it is a one-dimensional array, okay, it's a one dimension, you see it's a one dimension, it's a 1D array, you will see there will be one square bracket around these values. We have just one square bracket, it's a 1D array. Okay, we will see two-dimensional array in a few minutes, and then you will see that we have multiple square brackets around these values, and that will also be a matrix. Okay, so these functions, you see, these are the functions that I directly call from NumPy, okay, from NumPy library, to find the mean, max, median, and to find the position of minimum value, and to find the position of the maximum value. Okay, but you can also use object methods. Object methods mean that that's a variable, that's an object we have now, and now I'm going to, you see, that's a mean, that's an object, and then mean, and you will see it will also print out the minimum value. Okay, before that I use np.mean. np.mean means that's a function. np.mean, here that's a function we call, and here I use object function, object methods. Okay, so it's up to you, whatever you like, but I'm explaining the difference, that you can also have function, and but you also have, at the same time, you also have methods. All right, and another important thing in NumPy is that we only work with numbers. Okay, we only work with numbers, decimal numbers as well. For instance, let's say student GPA. Okay, these values will be decimal, and that will be np.array, and we have, let's say, 3.3 and 3.6 and 3.9. How many students we have? 1, 2, and 3. And if you, again I have a typo here, student GPA, and if you print out, you will again see that's it's a one square bracket around these values, and it's a one-dimensional array. And if, can we use shape here? Yes, the shape is 3, it's just a one row, 3 values there. And what else we, and it's an important thing, that the type, okay, that if you look at the type, you will see that it's a NumPy ND array. Okay, these are decimal values. And compared to list, okay, compared to list, there is a one difference that we'll see in a few minutes. Again, I will explain that one in a few minutes, but before that, let's now look at functions that we widely use to work with numerical values. Okay, so we have, let me show you. Okay, that's an array. We have array calculations, okay, that we have seen, and widely used functions are here. You see, np, so these are function, np sum, np mean, np max. Okay, and we haven't seen sum. Okay, that will be np.sum and student GPA. You will see it will sum all these values. That's 10.8. This is just a sum. Let me show you that. I'm now going to just copy this value, and you'll see the sum will be 10.8. okay, and here, okay, 10.8. all right, and now let's look at the difference between lists. Okay, the list, in list we have multiple data types. You see that one? Let me create a list that now we have std info. Let's say that's a variable we have, and I didn't use any np array because it's a list, and the first value is 10, and the second value is, let's assume, 67, and the third value is, it's just let's assume a name, and then the fourth one, let's say it's 10.9. You see, I use different data types. It's a list. Why I'm trying to explain that one? Because let's look at the type. Okay, the type is, it's a list. Okay, you can put multiple values there, multiple data types there. But with uh, NumPy arrays, okay, let me copy this one again here. Let me copy and let me put another value that will be, let's see, the GPA is 3.9, GPA 3.8. Okay, we have now 4 values, and let me print out to explain the difference. Okay, that's the important one. So these are the values we have, and you can put multiple values. Let's assume multiple data types again, sorry, and let's say that's a string value there, but it's an NP array. Okay, you will see the difference that these are all values that we have, 3.3, 3.6. These values become a string, because you see that this single quotes appears there. That's a very important difference, because now you cannot apply mathematical operation directly on this array. Okay, that's the main difference again. Okay, so you can only work with numbers. Okay, numbers to find mean, max, median, and also apply Boolean filtering or maybe any other function that we can apply on numbers. All right, so we have seen arrays, and now let's, so we already have seen indexing. Yes, we have seen indexing. Now let's move to slicing. Slicing is very similar to list. Okay, slicing is very similar to list. Let's see, I just need first two values that we have, student GPA, and that will be start from 0. Okay, 0 first index, and I need the first two value means 0, 1 and 2. Okay, you need to print 3.3 and 3. It's an up to, not including the second index. Okay, that's a slicing. And if you do not provide ending, it will extract all the values. And if I need to start from, let's just say 3.6, the first index, you need the first index, and you leave again ending, it's from start from 3.6, 3.9, 3. All the values we have in this NP array. Okay, again, it's an NP array, it's not a list. All right, and then you can also apply Boolean filtering. Boolean filtering mean, let's just put few more values, and let's say 2.5 here, 6, oh no, we do not have 6, and 2.3 GPA, and then we have 3.3, and then we have 3.1. These are few more values I introduced just to explain how to also apply Boolean filter. Boolean filtering mean, now I need students where GPA is greater than 3. Okay, and that will be student GPA, and I need greater than 3.0. Okay, you will see that's a mask, and that's very similar to list we have, and that's the mask we have, and it's in an array, it's in a type of an array. Okay, I'm going to put this as a variable, that's a mask. You see the first one is true because 3.3, 3.6 is true, 3.9 is true, true, false, false, true, true. Okay, and that's a mask we have. And now if I need to apply filter, that filtering we have seen using pandas, and that will be the same variable, and we just need to forward the mask, and that's the value where GPA is greater than 3.0. Okay, these are all the values we have. All right, and then you can also apply mathematical mathematical booleans, or these are arithmetic operation directly in arrays. That's the thing, that's the important thing. That mean, let's say we have sales values. Again, that's the sales values, 10, let's say 12, 20, 13, and 15. Okay, and let's say 16, and then 90. These are few values. Oh, it's a list. Okay, that's a list. We need to make it NP array. Okay, because this is how we can apply a mathematical operation directly in an arrays. Before it was a list. Just remember, now it's a NP array, and we can confirm that using print. The first thing is that you will see one square bracket around it, and the second one is the type. Okay, if you put the type, and you will see that this is NP NumPy ND array. Okay, and applying, let's say I need to multiply these values with uh, let's say 5. Okay, and that will be sales into 5. Okay, that quickly apply this mathematical operation directly on an array. You see, 12 into 5 is a 60, then 10 into 5 it's a 50. Okay, this is how you can also apply mathematical operations directly in an arrays. Okay, and what else we have seen min and max, and slicing we've seen, indexing, slicing, common. Okay, that's we already have seen, finding positions, boolean. Okay, now let's move to two-dimensionals. Two-dimensional means that we have row by columns. Okay, two-dimensional is a format of table, and we have rows and columns. Row and columns mean this is how many rows we have, 1, 2, and 3 rows, and we have column 1, 2, and 3 columns we have. Now let me copy this one, and we will see how to extract values, and also see another difference that is important to look at the shape. That will give you an idea that it's a one-dimensional or two-dimensional or multi-dimensional, because sometimes we work in multi-dimensional arrays. For instance, in natural language processing, I have seen dimensions of 768 dimensions. Okay, this is how these machine learning models works. We have to forward multi-dimensional arrays to model, and then they predict and define the pattern from these numbers. And NumPy is also very important there as well. Okay, so these are the values we have, and now let me print out print, because I like to show you the difference in the print. Okay, you see now we have two square brackets, that means a two-dimensional. Okay, and in case I need to extract values, so we have row by column. Okay, before it was just a row, one-dimensional, and now let's see, look at the shape. It will print out that we have 3 by 3. 3 by 3 means 3 rows 3 column, 3 rows 3 column. And if I need to extract 115, and that will be with square bracket or curly bracket, let me see, square brackets. Okay, and 115 is on 0 first row. Okay, first row 0 1 first row, and the column is 0 and 1. It's a 1 1 1 1. Okay, we have 115 there. Okay, now let me print. It's in 64 and 150. So in first row first column, first row first column. Okay, and let's see if you need to extract 110. That's a 1 2 0 1 and 2 second row and second column, right? Let me show you. This is 2 by 2 by 2. The 110 is there. Then we have, in the slides you will see different use cases there. Okay, use cases mean to find, this is how that's the functions we have to find the sum of columns and sum of rows as well. And axis 0 is axis 0. If you provide another parameter, axis 0 mean that it will give you sum by columns, and if you give axis 1, then it will give you sum by rows. Let me explain. So let's say I need to find that's an np dot sum, and I need this sum of values. Okay, by column, x is equal by rows. If you give x is 1, then it will be rows. Okay, it's saying 1 405 43 45, and rows mean you are trying to sum the first row, and then you're trying to sum the second row, and then the third row. Okay, now you left with now 1D array. You see there's a one square bracket around it. 405, because 120 135 plus 150 is 405. Okay, that's That's a uh, function. Sometimes we also need to find the sum of rows. This is important when we are dealing with sales data. Okay, for instance, that's a sales data. We have to find the sum, mean, max, and also find argmax is the highest value position. Okay, that's also important in searching. Then few other use cases we have: stock level check. Okay, that's the boolean filter we use. Okay, and where stock level is less than 10, okay, that's a minimum level, and it will print out values. And then price update. Okay, let's say you need to increase the price of your products 100, 150, 250, and you're trying to increase the price with 0.110%, and it will increase the price. And then we have monthly change. Monthly change means that you need to subtract a value next to it. That's 135 minus 120 is 15. The change is 15 the next month. And that's again, these value, these use cases mostly used when we are dealing with business data. And it's also important, not just in business data. Whenever you need to find the change, that's NumPy will provide you these functions. Okay, and the function name is np difference. Okay, and yes, that's it for NumPy. Okay, so NumPy is mostly used for doing numerical calculations. And the functions are very similar to list. We have slicing indexing similar to list. And difference is that we also see that we only work with numbers, because if you put string values in np array, those values will become strings, and you cannot apply uh, mathematical operations on those string values, because those are not now strings. Those are not now a number, those are strings. Okay, and what else? Then we can also apply boolean filters. And if we have data in 2 dimensions, then we have rows by columns. And yes, that's it for NumPy. That's it. And in the next class we will see matplotlib. Matplotlib is now the first library that we're going to see in to visualize the data.